right, 2 and then plus or minus 1. Probably should have. I'm gonna make this 1 right there instead. All right, and then 2, and then negative 1. And some of you guys forgot to put the y-intercept on there. You have to put that on there too and label it. Okay, the 2. All right. So now let's start with the graph. What's going to start it here is the end behavior. So x cubed, you have far left. All right, rise to the right. All right, now all the multiplicities were odd, so on each intercept, all it's going to do is just pass through it. Okay, so it's going to pass through negative 1, pass through the 2, pass through that 1, and then pass through this 2. Looks something like that. Okay, number 3. Let's see. All right, this one you had to factor this one too. We had x cubed minus 8x squared plus 16x. So you notice first here you can factor out x. And that'll leave me with x squared minus 8x plus 16. Okay, now let's factor. What are factors of 16 that'll add to give me 8 there? Yeah, 4 and 4. So x times. It would be minus 4, wouldn't it? Okay, x minus 4 times x minus 4. So yeah, let's just say x minus 4 quantity squared. That way we can spot in, not in behavior, but multiplicity better. All right, so now our x-intercepts are going to be 0 and 4. And let's note that this one's going to have multiplicity of 2. Okay, you're right, it's going to touch and turn around. All right. Now, the y-intercept, we got a shortcut on this one. We said about y-intercept if we knew this. If the x-intercept is 0, so is the y-intercept. Okay? And if you look and you can tell what the constant, there is no constant, would be 0. All right, now let's sketch our graph. Okay, so we got 0 and 4. 0 and 4. Okay, now let's get it started with end behavior. It's x cubed again. So fall left, rise right. Okay, now at 0, all right, it didn't have any it just had multiplicity of 1, so it's just going to cross through. And then at 4, it had a multiplicity of 2, so it's touch and turn around. All right, let's see, number 4. Negative 4 times x minus 1 quantity squared times x squared minus 9. Probably should have wrote that down like this. What, x squared minus 9, that's x plus 3, x minus 3. It's a difference of squares. All right, so now it's already in factored form. Let's just rattle off the x-intercepts. So x-intercepts are going to be 1, and I have a multiplicity of 2, and then negative 3 and positive 3, so plus or minus 3. All right, so let's note this one's got multiplicity of 2, and these are just odd. Okay, so they'll just pass through the 3's. All right, now here, and a lot of people miss y-intercept here. Okay, so remember, my y-intercept is where x is equal to 0. Now the other way we said it was the constant, but it's in factored form. You really can't tell what the constant is. All right, so you got to plug in 0 for all these x's and just multiply what you got left here. So we got negative 4 first. Now if we plugged in a 0, negative 1 squared, but that would just be 1. And then here if we plugged in 0, this is just going to be negative 9. Okay, so that's going to give me a positive 36. Okay. A lot of us, missed the y-intercept there. All right, let's plot all that on here. So we got plus and minus 3. All right, and 1. And then we got a y-intercept way up there, 36. All right, in behavior, let's go back up. Okay, so we're going to multiply. What would the leading coefficient be if I multiplied all of it out? So we got negative 4 times x squared times x squared. So that would be negative 4 x to the 4th. So that would be the leading coefficient. So if that's the leading coefficient, the end behavior is going to go, fall left and fall right. Okay, so now at negative 3, didn't really have any just odd multiplicity, so it's going to pass through. It's going to pass through 36. Now, what about 1? You had a multiplicity of 2, so right, it's going to touch and turn around. And then at 3, it's just going to pass through. All right, is that one all right? All right, do we need to do number 5? Yes? Okay. All right. On this one, x cubed times x minus 3 quantity squared times x plus 5. All right, so now x-intercepts, they're going to be, what for that one? 0, 3, and negative 5. Okay, so a lot of multiplicity in this one. This one's got multiplicity of 3, and then this one's got a multiplicity of 2, and then this one's got multiplicity of 1. So you have odd multiplicities here, so these are just going to pass through. But then this one, when I get to 3, it's going to touch and turn around. Okay, and really, it's going to, it's going to snake through. Okay, and that's really not that significant because you're not in calculus yet. So pass through would be okay. All right, but actually it will have an inflection point. It'll snake through it. Now, let's plot all these. Oh, I forgot something. Y-intercept. Okay, y-intercept is where x is equal to 0, or we can spot this. If the x-intercept, we have an x-intercept of 0, then we'll have a y-intercept of 0. Okay. All right, so it's going through the origin. All right, so we got 0, 3, negative 5. All right, let's get in behavior going. So my in behavior, all right, we got, let's see, x cubed times x squared times x. So the x to the 6th would be our leading coefficient. So that means it would rise on both ends. Yeah, a lot of people missed in behavior on this one. All right, so negative 5, multiplicity of 1, so it's just going to pass through. All right, it's 0, it's got odd multiplicity. Now, when it passes through that, it'll have an inflection point, so it'll look like that. And then at 3, it had multiplicity of 2, so that means it would touch and turn around. All right, on the back side, what I noticed, a lot of where we had trouble at, like on 6 and 7, it wasn't so much like getting the graph and like answering it, it was factoring. You missed a lot of factoring stuff. Signs on your factoring. Okay. All right, you want to look at some of those out of 6, 7, and 8. Which ones? Number 6, okay. Alright, so you have 5x squared plus 7x is less than 6. And you can do these on a number line. Okay, but we found it was easier just to sketch the graph since we know how to graph polynomial functions. Alright, let's see, let's set it equal to 0 so we can find out the intercepts. Not equal to 0, but less than 0. Alright, and a lot of people miss, they didn't maybe split and group. They said factors of 6 that subtract to be 7 was 6 and 1. We can't do that. Alright, well, we're looking for factors of 30 that subtract to be 7, 10 and 3. Okay. And a handful of you missed the signs here, so I'm going to go slower on your signs. They're going to be different. And then this will go in front of the bigger one. So plus 10 minus 3. And 10 minus 3 does give me 7 right there. Okay, now let's group them. All right, so I can factor out 5x right there. So I'm dealing with x plus 2. And then negative 3, that'll give me x plus 2. And pull that one out. All right, now we should be able to sketch our graph out here. All right, so my zeros are going to be negative 2 and 3/5. Okay, in behavior is rise right and left. And multiplicities were only 1, so it's just going to pass through. Okay, so basic parabola. Now, less than would be parts of the graph that are under the x-axis, so it's going to be these parts. So that's the piece of the graph that's in between negative 2 and 3/5, if I put that in interval notation. Now it's just less than, and that less than are equal to, so we don't include them. Okay, what about 7 or 8 here? Both of them? Okay. All right, let me say this on 7. Not so much in here, but like in second period, a lot of people, they try to be, a little bit clever and move everything over to the right side. Don't do that with the inequality. When you're solving an inequality, try to keep that variable on the left side, okay? Because it messes everything up. If you don't, everything kind of goes backwards. So what I was referring to here, it kind of looks maybe like it's easier to pull the x over than it is, but that makes it negative. And here we want to keep all the variables on the left side of an inequality. It's not like an equation. If it was an equation, I'd be all for that. But you set yourself up really to miss that if you do that. Now let's factor it. This one factored a little bit easier. Factors of 3 that subtract to give me 2 would be 3 and 1. Okay, so we have different signs. The minus 3 plus 1. Okay, let's sketch our graph on it. It's really, really similar to that number 6 there. So 3 and negative 1. In behaviors, and they're going to go up on both sides. Okay, just pass through, so it's just like the last one. Less than or equal to zeros. This part, I think the only difference was this was equal to, so you had brackets instead of parentheses like on number 6. All right, number 8. All right, this one wasn't a parabola. Wasn't a quadratic one, in cubic here. So you had x minus 2 times x minus 3 times x minus 4 is greater than or equal to 0. All right, so I can pretty much go straight to the graph because it's already factored. All right, you got zeros of 2, 3, and 4. Okay, but now, what would be the end behavior? Yeah, x cubed. Y'all see where it would be x cubed? Okay. Yeah, yeah. You can guess and check on number lines on these two. All right. So you rise right, fall left. In fact, that's the way most teachers show it. Okay. I like the full-fledged graph. It's just cooler. All right. Each one you're going to pass through. It's just going to do that. Now, greater than or equal to 0, we're looking for the pieces that go above. Okay, so it's going to be these two pieces. So now we're in between 2 and 3. Be inclusive. Yes, sir. She's not here this morning.
All right, thank you.
All right, and then go to the union symbol, from 4 to infinity and beyond. All right. Okay, 9, 10, 11. 11, okay. Annie, do you want it? You can have it. Okay. All right. Now, I didn't really particularly care the way 11 worked out. What happened is you only had one critical point. Okay? So, this is what it's... I'm not going to promise you it's not going to be that way on the test because I may have screwed it up too, but I think what I'm going to do on 11 here, let's just work it out a little bit differently, as in I'm going to change the problem, okay? So I'm going to change it so it'll actually have 2 critical points instead of 1. Instead of that 1 right there, let's make it a 2. Okay? And so let's just completely redo this one. All right? So now, these are rational inequalities. On rational inequalities, they have to be set to 0, and they can only be one fraction. Okay? So I've got to pull the 2 over, and I've got to combine it here, which means I've got to get a common denominator. So common denominator is going to be x minus 3. So we'll just bring this down. All right, but right here, I'm going from like 1 to x minus 3, so I'm going to have to multiply this by x minus 3. So that's going to give me negative 2x plus 6. All right, now let's clean it up. X minus 2x would be negative x, and then 14 and 6 is 20. All right, now this one, we don't know how to graph this one, so we plot and guess and check on our number line. So our critical points, well, x minus 2x plus 20? Oh, I don't know. Somebody else did that. Well, I guess I can't do that because it was recorded. It was me. I'm sorry. I'm guilty. All right. My bad. Now, all right, here we go. I'm like on the short bus on this one. Can't do it. Now I can do it. All right. It would be negative 20. Nope. Wait. 20. 20. Okay. And then the other one would be 3. Okay. Now, we're going to test an interval. And we're going to test 0 because he's our favorite. That would be the first interval right there, wouldn't it? All right, so let's see. If I tested 0, that would give me a positive over a negative, which is a negative. Oh, wait a minute. I'm looking at the wrong one. Let's back up. All right, still be positive over a negative. Never mind. It's a negative. Negative is not greater than or equal to 0. So A is not in the solution. Solution would be in between 3 and 20 because this doesn't work, this one does, this one does. Now, we've got equal to, so we can be inclusive here, but I cannot include 3 because it's going to make it undefined. So parenthesis on 3, bracket on 20. Okay, 3, 20, that's the way it'll be on the test. Okay.
So like on number 11, what was the answer?
I think what happened on 11, the only critical point you wound up with was 3.
How many were these?
Supposed to be 9. I counted them as 7. That way if you did miss one, you still made an A. Okay. Alright, now I'm doing this on the test. I put a few more problems on the test. Y'all didn't really have an issue finishing it, so I thought if I put a few more, you wouldn't. And that way it give you like a little bit more leeway. You know, if you miss one, it won't like kill you. Okay? Yes, I want you to. So you need to study those. Yeah, if you did make an A, you need to put it back in the tray for me so it can be recorded. All right, test Monday. Are we okay on 9 and 10?
Yeah.
Okay. I think on number 9, it was negative.
So -1.
Yeah. See, 7 to infinity. All right. Yeah, number 10, just check with somebody. I've got one in front of me, but they worked it wrong. All right, now.